In this video, we're going to be covering isotopes and how to calculate atomic mass as found on the periodic table. So first, to start off, we need to go over a certain notation. This is called isotope notation. Mass numbers can be written after the atom's name, so just to be aware of that. So for example, that 40, the 40 right here, the 40 right here is the mass number, and you can write that after the name. So you can call it calcium 40 like that. And the purpose is to specify the type of calcium. So there might be a calcium 42, and that would be written like that. So the calcium 42, for example, would have 2 extra neutrons compared to the calcium 40. And so you would say calcium 42 is a heavier version of than compared to calcium 40. Okay, atomic masses. So this is to cover, like, if you look at your periodic table, you'll see on the square, you'll see atomic masses. Like, for instance, you'll see a 6, C, and you'll see 12.011 for carbon. And this number is determined from a weighted average of all the known isotopes present. And an analogy is kind of like a class that uses weighted grading. For general chem, I don't use weighted grading, but you might have another class this year that does. For my EP class, I do use weighted grading. This is kind of how it works. So it's not like now this is a different type of average. You don't take like the 4 students at your table, and then you want to get the average height. You don't add this, this, and this. You don't add these heights together and then divide by 4. So it's not the same. This is totally different. So a weighted average is you use the weights or percentages, and then you multiply each amount by those percentages. So an analogy that you might see is a grade. So let's say in the first grading period you got a 79, the second grading period you got a 90%, and then the third grading period you got a 97, and the final exam you got a 95. So let's say each grading period is weighted by 30%. So it goes 30, 30, 30, and then the final is 10% of the overall grade. So you would take those weights or percentages and you would convert them. So you would take when you multiply percentages, you want to move the decimal. So you want to divide by 100. So this would be times 0.30. Okay, and then so would this also, and so would this one. This would be times 0.10. So we multiply these. So divide by 100, like I was saying, and then you get 23.7. Do the same for the second grading period, and then do the same for the third grading period, and then do the same for the final, and you get then you get 9.5 here. And then what you do is it says take the sum of all the weighted amounts. So if you add all these numbers up together, you're going to get, let me add these in my calculator. So you're going to get 23.7 plus 27 plus 29.1 plus 9.5. And this comes out to an 89.3% overall. That would be the overall grade. So if you did a little bit better on the final, or probably it was this grading period here, if you got like 1% better here, so if this was an 80%, then you would wind up with a higher weighted average, and you would have an A instead of a B. So here's how that works for atoms. So we're going to take chlorine, as it's a mixture of 2 known isotopes. So chlorine 35 has this mass, has a mass of 34.969, and 75.53% of chlorine is this mass isotope. And then the remaining 24.47% is this mass right here. So we're going to try to calculate the average atomic mass for chlorine. So the way you do it is let's set up like a formula. The atomic mass, I'll just write out the whole thing. Atomic mass equals, and you take the fraction of isotope 1, multiply it by the mass of isotope 1. Okay, and then you add it to the fraction of isotope 2. Notice I'm saying fraction because these are in percentages, so we're going to have to change those to fractions by dividing by 100. Fraction of isotope 2 times the mass of isotope 2. And then you would, if this had more isotopes, so some elements have, like I think it's sulfur. No, maybe it's not sulfur. Yeah, I think it might be sulfur. It has like 8 known isotopes. So you would actually do this 8 times. So you would do it for every single isotope. So I'm going to write plus, and I'm going to write dot dot dot, and the dot 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 means you would continue doing this for how many ever isotopes it has. Okay, so this number right here, the 75% matches with this. That's this isotope. So we're going to call this 0.7553 times 34.969. And then we're going to take this percentage for this isotope and it times it by this mass. So we're going to go 0.2447 times 37.01. Okay, and then you could do this in your calculator. So here's my calculator, and I'm going to enter it like this. So 0.7553 times, actually I'm going to add my parentheses, and then 34.969, close parentheses, add to the next fraction, the next isotope, which is 0.2447 times 37.01 equals, and I get 35.47. So I'm going to write 35.47. I'm going to write AMU, atomic mass units. Okay, it should match up with what's on the periodic table. You'll notice that on the periodic table I'm looking at right now, it says 35.45. So periodic table right now says 35.45, and it's just because of rounding. So if you actually look up these isotopes, this number probably goes out a lot further. These numbers actually go to like 8 decimal places, as far as 8 decimal places, and these are also rounded also prematurely. So it's just because of rounding error, but you should get what's on the periodic table like pretty close. Okay, so now it's one for you to try. Let me go to this one here, and this is one for you to try. Okay, it says silicon has 25 known isotopes. Most of those are trace amounts, so it's almost immeasurable. That's how low they are. So it says the most abundant are silicon 28 at 92.23%, and silicon 29 at 4.67%, and silicon 30 at 3.1. So this is based on these numbers. What's the atomic mass of silicon? Okay, so set it up just like the one I did, and just make sure the work that you show the entire equation. Okay, so you want to show it like just like how I did. So you go atomic mass equals, and then put your numbers in, and then this is the work that I would like to see. So the fraction of the first isotope, second isotope, and notice you have 3 isotopes on this one. So this is what should be written to your work here. Okay, and then equals. And then make sure you read the problem so that you could get the numbers in correctly, and make sure you change the percentages to fractions.